All right, sets 4. So we'll start out by talking about subsets. And it said that A is a proper subset of B, denoted as you see it there, when all the elements in A are also elements in B, and at least one element in B is not an element in A. So A is a proper subset of B when all the elements of A are also elements in B, and at least one element in B is not an element in A. Let's have a look at this example. Example 1. The universal set U is defined as the set of integers between 1 and 10. So U is the set of integers between 1 and 10. E and F are subsets of U such that E is the set of even numbers and F are factors. F is the set of factors of 8. List using set notation the elements of A of the set U. So we're to list using set notation the elements of the set U. Well, that's not difficult. We were told that U is the set of integers between 1 and 10. So U would be like 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. The numbers 2 to 10, counting numbers, are integers 2 to 10. Those are the integer values between 1 and 11. When it says between 1 and 11, it means that you must not include 1 and you must not include 11. E is the set of even numbers, so that would be 2, 4, 6, 8, and 10. F is the set of factors of 8. So the factors of 8 are all numbers. It can go into 8 without even a remainder. So those would be like 2, 4, and 8. 2, 4, and 8 are the factors of 8 between 1 and 11. D is asking us to list the elements of E intersect F. Now, remember, when you hear the word intersect, you should be thinking common. So E intersect F is a set of all elements in the universal set which are common to both E and F. So if I want to list the elements of E intersect F, I must look at E and I must look at F, and I need to list all elements which are common to both E and F. So the elements that are common to both E and F are like 2, 2 is in both E and F, 4, 4 is in both E and F, and 8 is in both E and F. All right. So if you look carefully, you can see that the set E intersect F and the set F are equal sets. So E intersect F and the set F are equal sets. Why? Because they have the exact same elements. So I could say that E intersect F is equal to F. All right. Now, E union F. Now, if I wish to list all the elements of E union F, I need to look at the set E and the set F and list all the elements which are in both what E and F. So the elements which are in both E and F are like 2, 4 is in E and F, 6, 8, and 10. All right. Again, if you look carefully, you'll see that E union F is the same as the set E. E union F is the same as the set E. The two sets are equal sets. All right, so the next thing we want to do is that we want to draw a Venn diagram of the information. So the information that we're talking about is U, E, and F. Now, before we start drawing, what we want to note is that what is important to note is that all the elements of F are also elements of what E. All the elements of F are also elements in E. And there are elements in E which are not in F. So under such a situation, in such a situation, we say that F is a subset of what E. All right, let us see how would we represent that on a Venn diagram. So in the Venn diagram, we have U, the universal set. We already saw that F is a subset of E. And that simply means all of F is inside of E. Now the elements of F are 2, 4, and 8. Alright, now the elements, all of F is in E. The elements which that are in F, that are in E, which are not in F, are 2, 4, 6, 6, and 10. And now the elements which are neither in E nor F are 2, 4, 6, 8. Sorry, 2. So we should have like 3, 4, 5, 6, 7, 8, 9, and 10. All right. So this would be what my universal set looks like. Note, F is a proper subset of E. It means all the elements of F are also elements in E, and that there are elements in E which are not in what? F. This is how you draw your Venn diagram when you have a proper subset. Let's go further. All right. In this example, example 2 says, in each of the following, label the shaded region using set notation. In each of the following, we're to label the shaded region using set notation. All right. In diagram 1, in all the diagrams, the 3 diagrams, A is a subset of B. And it means all elements of A are also elements in B, and that there are elements in B which are not in A. Now, if A is a subset of B and you shade, what we have shaded here is all of B. If you look carefully, you can see that everything in B is green. So what we have shaded is what is B. All right. Or if A is a subset of B and you shade all of B, you have also shaded A. Now, if you shade both A and B together, what you have shaded is what? A union B. So if A is a subset of B, if A is a proper subset of B, B is the same as what? A union A. A union B. Also, if you shade all of the elements of A and B together is A union B. But all the elements of A and B are all in B. So if you shade B, what you have shaded is B, or you can say it is A union B. All right, diagram to the right. Well, in the diagram to the right, what we have shaded is what? What we have shaded is we have shaded A. Simple. Um, but if you look carefully, or we could say that this is A intersect B. If A is a subset if A is a proper subset of B, A is the same as saying A intersect B. All right, that shaded region is common to both A and B. If elements are common to both A and B, what you have shaded is what? If you have shaded an area that is common to A and B, what you have shaded is an area that corresponds to A intersect B. In diagram 3, we note carefully that the shaded region is in what? B, but it's not in A. Now, if an element, so, all right, let's just say the shaded region, let's say I'm going to put an element in it X. We can see that clearly that X is not an element of A. Now, this automatically means if X is not an element of A, X is automatically an element of A complement. Now, X is clearly an element of what? B. So X is both an element of A complement and B. So I could say that X is common to A complement on B. So if X is common to A complement on B, the shaded region here represents A complement intersect B. The shaded region represents A complement intersect B. That is where you have elements which are common to both A complement and B. All right, I've been sort of saying this, but let us highlight it here. What this says is this. If A is a subset of B, if A is a proper subset of B, A intersect B is equal to A, and A union B is equal to B. If A is a proper subset of B, A intersect B is equal to A, and A union B is equal to B. It's something that you can look at to ensure that you can clearly understand it. All right. The next thing we need to look at is disjoint sets. And this says two sets A and B are disjoint sets if A intersect B is a null set. So if A intersect B is a null set, it means that A and B are disjoint sets. Let's have a look at an example. This says example 3. Now in example 3, we're told that U, the universal set, is the set 53, 54, 55. So it's a set of counting numbers from 53 to 59 inclusive. M is the set of prime numbers. N is the set of even numbers. All right, list using set notation the elements of M. So the first thing is that we need to be able to identify the prime numbers between 53 and 59 inclusive. All right, a quick way to sort of like evaluate a number, if a number is a prime number, is to see if the number can be divided by 2, 3, 5, or 7. If the number can be divided by 2, 3, 5, or 7, it is not a prime number. Clearly we can see that 53 cannot be divided by 2 because it doesn't end with an even number. 53 cannot be divided by 3 because the digits 5 and 3 do not add up to do not 5 plus 3 is 8, which is not divisible by 3, therefore 53 is not divisible by 3. 53 cannot be divided by 5 and it cannot be divided by 7. So 53 is a prime number. 54 isn't, 55 is not, 56 is not. Let's look at 57. 57 is also not a prime number because 5 plus 7 is 12. Since 12 can be divided by 3, 57 can also be divided by 3. 58 is a prime number, sorry, is an even number, and therefore it is not a prime number because the only even number that is a prime number is 2. The next prime number is therefore 59, is 59. All right. Um, n are the even numbers. So the even numbers would be 54, 56, 58. All right. Those are the even numbers between 53 and 59 inclusive. All right. Next, we need to list all the elements of what M intersect N. If we wish to list the elements of M intersect N, we need to look at M and N and identify all the elements which are common to both M and N. If we look carefully, we can see that there are no elements which are common to both M and N. There are no so if an element is common to M and N, that element would be in both M and N. And since there are no elements which are common, M intersect N is a null set. And since M intersect N is a null set, M and N are disjoint sets. Now, M union N. Alright, if you wish to list the elements of M union N, you need to look at M and N and list all the elements in both M and N together. So that would be like 53, 54, 56, 58, and 59. Those are the elements in M union N. Alright. Next we are asked to what? Draw a Venn diagram, a clearly labeled Venn diagram of the information. Alright. So here is U, our universal set. There is M, which is the set of prime numbers, and there is N, which are the even numbers. The prime numbers are 53 and 59, and the even numbers are 54, 56, and 58. The numbers which are neither in M nor N are the numbers which are neither in either M or N are 4, 55, and I think also 57. All right. So this would be a Venn diagram of my information. Please note that there are no elements common to both M and N. Therefore, what the two subsets M and N are separated. There are no elements which are common. If there are elements if you had common elements between M and N, you'd have to overlap the two sets. But if there are no elements which are common, the two sets are disjoint and you must what? Separate them. Alright, example 4 is asking us to what? Label the shaded region using set notation. Alright, in the first diagram, what is shaded is what? A and B. If you have shaded A and B together, what you have shaded is A union B. Because A union B would be all elements which are in A or in B or in both A and B. So once you shade all the elements of A and B, what you have shaded is A union B. Alright, over here, the white circles would represent together would be A union B. So the shaded region outside, which would be everything that is not A union B, and whatever is not A union B is A union B complement. All right. If an element is in the shaded region, if an element is in the shaded region, we can say that the element is not in A. So if the element is not in A, so we could put an element in there. Let us say we put an element X in there. We could easily say that X is not an element of A. Therefore, X is an element of what? A complement. If an element is not in A, it is automatically in A complement. X is not an element of B. Therefore, X is an element of what? B complement. So X is in both what? A complement, and it is in what? B complement. Therefore, X is in what? A complement intersect B complement. So the element X is common to both A complement and B complement. If it is common to both A complement and B complement, it is an element of A complement intersect B complement. All right, let's talk about the number of elements in A union B. Now, the number of elements in A union B is given by this formula. The formula says the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. All right, so this formula will come in handy, or can come in handy, let's say in a multiple choice question. Let's have a look at example 4. It says two sets A and B are such that the number of elements in A is equal to 8, the number of elements in B is equal to 10, and the number of elements in A intersect B is equal to 3. We're asked to determine the number of elements in A union B. All right, let's write that formula. The number of elements in what? A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in what? A intersect B. So let's put in our information. The number of elements in A is 8. The number of elements in B is 10 minus the number of elements in A intersect B, which is 3. So this is 18 minus 3. The number of elements in A union B would be 15. The number of elements in A union B using the formula would be 15. All right, example 5. In example 5, the Venn diagram below, in the Venn diagram below, the number of elements in P is 12, the number of elements in Q is 18, and the number of elements in A union B, P union Q is 25. We're asked to calculate the number of elements in P intersect Q. All right, that would be the number of elements in here. All right, so using the formula, the number of elements in what? P union Q would be equal to the number of elements in P plus the number of elements in Q minus the number of elements in what? P intersect Q. So let's put in what we know. The number of elements in P union Q is 25. The number of elements in P is 12. The number of elements in Q is 18. And the number of elements in P intersect Q is what we don't know. All right. All right, so let's just work this out simple. It's not difficult. Minus this goes over and become positive. So we have what? The number of elements in what? P intersect Q would be equal to 30. And positive 25 comes over and becomes negative 25. So the number of elements in P intersect Q is 5. All right. So the number of elements in the shaded region of the diagram would be 5. Example 15. In example 15, we're told that the number of elements in M union N is 42. In N intersect M intersect N is 7. in M is 20, and we're to determine the number of elements in N. Formula again, the number of elements in M union N would be equal to the number of elements in M plus the number of elements in N minus the number of elements in what? M intersect N. So let's put in what we know. This is 41. This is 7. This we don't know. Minus this, which is this is 7 actually. This over here should have been 20. So the number of elements in M was 20. Alright, let's carry these over, the 20 and the 7 over. So this is 41 plus 7 minus 20 is equal to the number of elements in N. So the number of elements in N would be 48 minus 20, which would be 28 elements. Alright, and the absolute last thing, arrangement of subsets. Now, whenever you have two subsets in the universal set, you could have one of three arrangements. For arrangement 1, there are elements which are common to both A and B. So you tend to have an arrangement like 1 when there are elements which are common to both A and B, and there are elements in A which are not in B, and there are elements in what B which are not in what A. Alright? Since it's a situation, so maybe we could put that down. There are elements in A which are not in B and vice versa. Alright, meaning that it's true the other way around. Alright, arrangement 2. In arrangement 2, A is a subset of B. So all elements of A, all elements of A are also elements in B. And at least one element in B is not in A. Arrangement 3. This is when A and B are what? Disjoint sets. A and B are disjoint sets. So here, A intersect B is equal to a what? Null set. In other words, there are no elements which are common to both A and B. So in such an arrangement, you would have what? You'd use diagram 3, all right? And that in diagram 3, A and B are disjoint sets. All right. So that's the end of this lesson on sets.